Hello, Wits It third graders. Mr. Saul here for another exciting science lesson. Today we're going to be talking about magnets and pushing and pulling magnets. Now, magnets attract different kinds of magnetic materials. We know that there are some metals that are attracted to magnets, but any magnetic metal will only be attracted to a magnet. You'll never see a metal that is repelled by a magnet unless it is also a magnet. So that's just what it says here. At the same time, when two magnets attract, they're going to attract with a much greater strength than if you just had a magnet and some magnetic metal. Why is that? Well, we're gonna have to put on our scientific detective thinking caps to find out. First, we need to come up with a good science question once again. So, how can we do that? Magnets attract to other magnets, but sometimes they repel them. In the space provided, write a scientific question that asks about these observations. So, teachers, this is a great time to pause. Students, remember, you're trying to come up with a good scientific question that can only be answered with an experiment. All right, welcome back. Hopefully you have a really good scientific question about why some magnets attract other magnets and why sometimes they repel them. Something like, why do magnets sometimes repel and sometimes attract other magnets? All right, as we continue, teachers, you might want to check in on the Florida Virtual Learning School lesson to see if you're on the right track here. All right, so just with any good scientific investigation, we have to come up with a hypothesis. That hypothesis is your really good guess or your prediction about what's going to happen. So to do this, we're going to be needing magnets with north and south labeled on their poles, just like I have ready to go right here. I don't know if you guys can see the north and the south on here, but it should be pretty clear. Let me see. You guys see that? Yeah, kinda. So there's the N and the S for north and south. All right, so the hypothesis means we have to guess what's going to happen when we set the magnets up like this. If opposite charges attract, then two north poles will what? Are they going to attract to each other, or are they going to repel and push away from each other? Okay, so with your teacher, you're going to go through and circle which one you think will be correct to complete your hypothesis. It's okay if you don't know. Remember, this is just a really good guess, a prediction. So we're going to do 4 different situations. 2 north poles, 2 south poles, a south pole and a north pole, or a north pole and a south pole. So you guys go ahead with your teacher, pick which one you think will attract or repel for each of these situations. All right, once you're done, now that we have our problem defined and we have our hypothesis, we need to go ahead and do our experiment to see if our hypothesis or our guesses were right or not. So, first thing we're going to do, I don't need that, so we're going to place one bar magnet on a table so it's free to move around. Then we're going to slowly move the other magnet's north pole towards the north pole of the magnet on the table. We're going to record what happens when these 2 magnets get close together, when they interact. Then we're going to repeat the steps 2 and 3 for the magnet sitting on the table, and we're going to record our observations for what each thing happened. So I'm going to pause real quick and set up a little demonstration area. All right, my friends, we are back, and I've set up my magnets on the table here so we can see really closely. Okay, so our first situation is that we're supposed to have 2 north poles pointing at each other. So I'll set my north here, and then according to the instructions on the page, it says place one bar magnet on the table so that the north and south poles are labeled and so that it's free to move around. So it is definitely free to move around here. And then next we need to slowly move the other magnet's north pole towards the north pole of this one. So here I have this north pole. We're going to slowly bring it in. Okay. So we're seeing some interesting interactions here. So describe how the magnet reacted to this first situation. All right. Once you're done with that, we're going to go on to the next one. This time we're going to look at what happens when two south poles interact. So I have my first one, south pole, my second one bringing in the other south pole. Oh, very interesting. Let's see that again. Okay, so in this case, we're seeing almost the exact same result, this time with the magnet spinning almost all the way around. All right? For our next situation, we're going to look at what happens when a south pole and a north pole interact. So I have my south pole ready. Turn this one around so I have my north pole and bring that in. All right, and we're seeing some strong interaction, different from the first two times, but still a really good interaction. All right, and finally, a north pole and a south pole. Let's switch those around. And what happens when those two interact? So it looks like we're only seeing two different results of these four situations. I wonder if you guys can describe what we're seeing. All right, so finally, let's describe what happens when the two north poles come together. Okay, then you're going to describe what happens when the two south poles come together. After that, you're going to describe what happens when a north and a south pole come together. Very good. All right, and finally, let's go back and answer our question from the very beginning of the activity sheet, which was, why do magnets sometimes attract and sometimes repel? And the answer is all about the poles. All right, folks. Thank you so much for another great science lesson with Mr. Saul today. I will check back in with you guys next week for another exciting lesson.